In this video, I will show you how to find unknowns when you are dealing with similar triangles. Your first step is always to match up your corresponding sides using the similarity statement. Don't assume that the x plus 3 matches up with 77, for example. X plus 3 is CE. CE is the beginning and the end of this similarity statement. So that's going to correspond with TS. And TS is down here, so these are the corresponding sides. Similarly, this is ED. ED is right here. That's going to correspond with US, which is right here. So these are corresponding sides. Okay, now pick one triangle and call it new, and call the other one old. It doesn't matter which one is which, as long as you set up your equation in the form new over old equals new over old. So look at the yellows. New over old would be x plus 3 over 2x plus 1. Look at the blues. New over old would be 42 over 77. Okay. Let's reduce this fraction. Both of these are divisible by 7. So that's going to give me 6 over 11. Now, if I lost you just then, use your calculator. Okay, 42 over 77. All right, you get 6 over 11. We reduce because smaller numbers are easier to work with and faster to work with. So next we're going to cross multiply. So let's look at this diagonal. So we're going to take 11 and we're going to end up doing the distributive property with it. So that's going to give us 11x plus 33. Now let's do the same thing with the other diagonal. So we're going to take the 6 and do the distributive property with that. So that's going to give us 12x plus 6. Hey, let's subtract 11x from both sides to get those x's together. That's going to leave us with 33 is equal to, well, 1x, or just x, plus 6. So to get x by itself, we'll just subtract 6 from both sides. So that's going to give us x is equal to 27. All right, now is that the final answer? No. Okay, so fine, we know that x is 27, but we're supposed to plug that in to find ST. Okay, so ST is 2x plus 1. All right, so ST is equal to 2x plus 1. But now that we know x is 27, that means ST will be 2 times 27 plus 1. So 2 times 27 is 54. So that means ST will be 55. And that is the final answer. Okay, let's do something similar for this problem. Let's match up the corresponding sides. So this is AC. That's the beginning and the end. That's going to correspond with DC. Here's DC right here. Never assume which ones are corresponding. Anyway, those are corresponding. So let's look at the 77. That's BC. BC is the last two. That's going to correspond with EC. All right, here's EC right here, so those are corresponding. All right, pick one triangle to be new and one to be old, and then set up your equation in the form new over old is equal to new over old. Looking at the yellows, new over old would be 14x plus 4 over 16. Looking at the blues, new over old would be 77 over 14. Now I'm noticing that both of these are divisible by 7. So let's reduce. So that's going to be 11 over 2. Again, if you need to, you can use your calculator. So we had 77 over 14. 11 over 2. All right, time to cross multiply. So when we do this diagonal, we need to multiply 2 times the binomial. All right, so we're going to do the distributive property right there. So that'll give me 28x plus 8. When we do the other diagonal, all right, that's just 16 times 11. All right, that is 176. So just subtract 8 from both sides. So that's going to be 168. And then divide both sides by 28. So that is 6. All right, and that's the final answer because we were supposed to simply solve for x. Let's match up the corresponding sides. So we have x minus 5, that's ME. Here's ME. That's going to correspond with FL. So here's FL. These are corresponding sides. Okay, the 8 is YE. YE is the beginning and the end. So that's going to correspond to FK. So here's FK, so these are corresponding sides. All right, now pick one triangle to be new and the other one to be old. It doesn't matter which one is which, but set up your equation in the form new over old equals new over old. If you look at the yellows, new over old will be x minus 5 over 3x minus 8. If you look at the blues, new over old is 8 over 28. I'm noticing that both of these are divisible by 4. So we should definitely reduce. So we're going to get x minus 5 over 3x minus 8 equals 2 over 7. If you didn't follow that, put 8 over 28 in your calculator. All right, 2/7. So that makes it easier to cross multiply, which is what we're going to do right now. We're going to take this 7 and do the distributive property with it. So that's going to give us 7x minus 35 equals. Time for the other diagonal, where we take the 2 and we do the distributive property with that. So that'll give us 6x minus 16. Let's get these x's together by subtracting 6x from both sides. That'll leave us with x minus 35 is equal to negative 16. Add 35 to both sides to get x by itself. All right, so that's negative 16 plus 35. And that's 19. All right, now, I don't think that's the final answer. We're supposed to solve for x, yes, but then we're supposed to plug it in to find FL. All right, FL is right here. It's 3x minus 8. Okay, but now we know x is 19. All right, so 3 times 19 minus 8. That is 49. So that is the final answer. All right, here comes the last problem. This one's going to be slightly more involved. Well, there's going to be an extra step. That's all I'm really saying. These triangles are overlapping, and this is not a good one to do the side splitter theorem because I have the 60, but I don't have, for example, this other side here. I have the 35, but I don't have this other side here. So I don't have the pieces to do the side splitter theorem. So when you have overlapping triangles and you can't do the side splitter theorem, what I recommend is draw the triangles separately. All right, so for example, here is the small triangle, and I'm just going to put that off to the side. I think I'll just stick it over here. Now, here is the large triangle. All right, let's put that off to the side over here. So let's label the sides. So the small triangle is WQP. So that's WQP. The large triangle is WYX. So WYX. Now how about the sides? Okay, the 60 and the 35 are sides of the small triangle. So I've got 60 and I've got 35. Now how about the large triangle? Notice that these lines reach from one side to the other. That's telling us that the long side WX is 5x minus 12. Similarly, from W to Y, this is telling us that that is 2x plus 15. So we've got 2x plus 15 right here. The rest of the problem is going to be just like always. We're going to match up corresponding sides. So, for example, I've got this 2x plus 15. That's WY. So here's WY. That's going to correspond with WQ. Here's WQ. So those are corresponding sides. How about 5x minus 12? That's WX. So that's the first two. That's going to correspond with WP. Here's WP. So those are corresponding sides. Now, pick one triangle to be new. I'm going to pick this triangle. And pick the other triangle to be old. It doesn't matter which one is which, as long as you write your equation in the form new over old is equal to new over old. Looking at the yellows, new over old will be 2x plus 15 over 35. All right, looking at the blues, new over old will be 5x minus 12 over 60. Okay, now let's cross multiply. All right, so let's do this diagonal. So I need to take this 60 and I need to do the distributive property with it. So let's see, 60 times 2 is 120. So I'm going to have 120x plus, let's see, 15 times 60 is 900. All right, look at the other diagonal. So we have to do 35 times this. So we're going to do the distributive property again. All right, so we've got 175x minus 420. Okay, let's get these x's together by subtracting 120x from both sides. So that'll give us 900 is equal to, I feel like that's going to be 45. It's 55. All right, now it's time to add 420 to both sides. So I'm going to bring down my 55x. So this is going to be 1,320. And then the last step is to just divide both sides by 55. And you get 24. Okay, that's the final answer since they just wanted us to solve for x.